Alright, so now we're going to talk about the first derivative test, okay? Now, it says suppose that c is a critical number of a continuous function f. Now, we got to remind ourselves what a critical number is. A critical number of a function is any number that makes the derivative equal to 0 or where the derivative does not exist, okay? So, suppose that c is a critical number, meaning we have to find these critical numbers. Then if f changes, if f prime, if the derivative changes from positive to negative at c, then f has a local maximum at c. Okay, so let me draw you a picture of what that's going to look like. Now again, we could see that we have a local maximum at that point C. Now, let's see, different color. Now let's read it one more time. It says, suppose that we have a local maximum. We definitely have a local maximum at C. So therefore, this C value is a critical number. And f changes from positive to negative at c. Sorry, if f prime changes from positive to negative. So f prime is the derivative. The derivative means slope. So if I look at the tangent lines right here, as you see, they all have a positive slope drawing these tangent lines. And as I go from positive, the derivative goes from a positive number, and now on the other side of C, I have downward sloping tangent lines. So I have a negative slope, and that's what it's saying. If the derivative changes from positive to negative at C, when going over it, then we know we have a local maximum at that value of C. Okay, so we could, without even graphing it, we can see whether our numbers, our critical numbers, are minimums or are they maximums. Now, you do have another analogous case to this. I'm going to erase my axis. And it's when we have a local minimum, okay? It's number 2, or letter B. It says if the derivative changes from negative to positive, then we have a local minimum at C. So, let's see, there's C right there. I mean, we could visually see that's a local minimum, but the first derivative test says if we were to go ahead and find the derivatives and calculate tangent lines, calculate all the little slopes, right? That here, the slopes are negative, 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 and then on the other side of C, positive, 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 positive. So when the derivative, if this is a critical number, when the derivative changes from negative to positive, then we know that we have a local minimum. Now there are 2 more cases. Remember, critical numbers are where the derivative is equal to 0. Or where it doesn't exist. Let's look at, remember the cubic functions that we talked about? And the cubic function had, I gave you guys a warning when using Fermat's theorem, that just because the critical number equals 0, doesn't mean we have since the derivative equals 0 at some critical number, doesn't mean we have a local min or a maximum. So here, if we were to draw little tangent lines, negative, 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 0 here, negative, 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 like that. Okay? So let's read C. If f prime is positive to the left and right of C, or if it's negative to the left and right of C. This one is negative, 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 negative to the left of C, and on to the right of C, negative, 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 negative. At C, it's equal to 0. Then f has no local minimums or maximums at C. Now, you could draw the same case for this is a negative cubic function. Here's a positive cubic function. This would be the first part of letter C. Positive, positive, positive. Here it's 0. Positive, 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 positive. Okay? Okay, so let's go ahead and do some examples to find where the local mins and local maxes are. And it's going to be using the first derivative test. So we've got our first function, f of x equals x to the fourth minus 2x squared plus 3. So first off, I'm going to find critical numbers. That's the first thing I'm going to do, is find the critical numbers. So to find the critical numbers, that means take the derivative. So 4x cubed minus 4x. And then I'm going to set it equal to 0. 4x cubed minus 4x equal to 0. So that's just the procedure just to find the critical numbers. We went through that in 4.1. Okay, so what I'm going to do is I can factor out at 4x. I get x squared minus 1 equals 0. So you have 4x, x minus 1, x plus 1 equals 0. Okay, so from here, we see x must equal 0, and from these two, x must equal plus or minus 1. So I'm going to write this up here. Critical numbers, x equals 0, x equals plus or minus 1. We don't need the original function. We do need the derivative. F prime of x is equal to 4x cubed minus 4x. Okay, so now we want to see where does the derivative go from being positive and where it goes to being negative, or the other way around, or does it always stay positive or does it always stay negative? What we're going to do is we're going to use the increasing-decreasing test and do the same procedure. But before, we were looking at where intervals worked and didn't work. Now we're going to care about the signs, and that's all we're going to care about. Is it positive on this interval or negative on this interval? Does it go negative, positive, something like that? Okay, so here's my interval. I've got -1, I've got 0, I've got 1. Unfortunately, we can't use 0 for one of our test values because it's a critical number, but we've got one interval there, a second interval there, a third interval there, and then I'm out of colors. I'll just use black again. So, it doesn't matter how you go about it. Let's find the increasing intervals. So, f prime of x is greater than 0. 4x cubed minus 4x is greater than 0. Now, we really want the factored form because we could easily plug numbers in. So, it was 4x, x minus 1, x plus 1, greater than 0. Okay, we're going to be plugging numbers into here, and again, we only care about the sign of the interval. So let's pick some test values. Test value, -2. Test value, 1/2. Sorry, -1/2. This one, 1/2. Test value, 2. Okay? So let's start with the test value, -2. Now, I know I set it up like the last problem, but we really only care about the sign. So if I plug -2 into here, you're going to get a negative number. If I plug -2 into here, you're going to get a negative number. If I plug -2 into here, you're going to get a negative number. Negative times a negative times a negative is a negative number. If we were doing the increasing-decreasing test, a negative number greater than 0? No, a negative number is not greater than 0. So in this interval, it would not be increasing. So that's doing examples from a little bit ago. But we just really care about the sign. So I will do this in a different color. Let's see. We're negative on that interval. Now, let's do our next test value. -1/2. So, just plug it in. If I plug a negative number into this first piece, it's going to be negative. If I plug -1/2 in here, negative minus 1, that's still going to be negative. Negative plus 1. Okay, we got to be careful. -1/2 plus 1 is positive 1/2, so we get a positive. Negative times a negative times a positive is a positive number. So right here, on this interval, the derivative is positive. So now, since it goes from negative to positive on at C, we're having negative slope to a positive slope. We know that at -1, we have a local minimum. Okay, we'll write all the results at the end. But let's go ahead and do the other two test values. I'm going to erase these. So now I've got a test value of 1/2. If I plug a positive number into this first piece right here, it's going to be a positive. Positive 1/2 minus 1, okay? Be careful. Positive 1/2 minus 1 is a negative 1/2, so that's negative. Positive number plus 1, well, that's still going to be positive. So here, positive times a negative is a negative, times another positive is a negative. So on this third interval, we have a negative number. Now the last test value, 2, well, plugging in the first piece, positive number here is positive. 2 minus 1, well, that's positive. 2 plus 1, that's 3, that's positive. All positives, that's going to be positive. So on this interval, we've got a positive number. So the first derivative test, let me recap for a second. First derivative test first said, find the critical numbers of our function f. So that means take the derivative, we set it equal to 0, solve the equation, we got these numbers. And then what it wants us to do is pretty much do the increasing, decreasing test, but only to find the signs of the interval. Okay? Now after we find the signs of the interval, we can write up our results. Okay? So let's find all of our local mins. So there's a local min at x equals, well, Let's see. Local minimums is letter B. If the derivative f prime changes from negative to positive at C, well, right here the derivative changed from negative to positive at our critical number C of -1. So we have a local minimum there. Is there another place where it goes from negative to positive? There is another place that goes from negative to positive, right here at +1. The derivative here is negative on one side of our value C. The derivative is positive on our other value of C. So I could put a plus here, plus or -1. And now we have a local max at x equals 0. Because 0 on one side of 0 goes from positive, and then to the right of 0 goes negative. We always go left to right. So it changes from positive to negative. We have to have a positive slope to a negative slope. We got a maximum there. Okay? It's called the first derivative test. It allows us to find minimums and maximums. Alright, so I do have another example we're going to go through. Let's see. F of x is equal e to the 2x plus e to the -x. Alright, so we need to find where this function, where the derivative is equal to 0. We need to find the critical numbers. So first we need the derivative is equal to, so this is 2e to the 2x minus e to the -x. Alright, so to find the critical numbers, 2e to the 2x minus e to the -x is equal to 0. Now we have to solve this. Now, instead of writing e to the -x, I'm going to write it as 1 over e to the x. Okay, so now what I'm going to do is I'm going to multiply both sides of the equation by e to the x. As you see, this right-hand side is not affected. 0 times e to the x is e to the x. But now if I distribute this here, I get 2e to the 3x, and then e to the x over e to the x, I'm going to get a -1. I guess I'll move over right equals 0. Right there. We have to solve this equation for that x value. So first step, add 1. 2e to the 3x is equal to 1. Now we're going to divide both sides by 2. E to the 3x is equal to 1/2. Next, I'm going to take the ln of both sides. So when I take the ln of this left side, the ln of e goes away, and I just end up with 3x is equal to ln of 1/2, and then just divide by 3. So I get x is equal to 1/3 ln of 1/2. This is my critical number right there. I'm going to leave it in exact form, okay? So we still need our derivative. I'm going to take our critical number, write it up here. X is equal to 1/3 ln of 1/2. Okay, so now we've got a number line, and somewhere on this number line is 1/3 ln of 1/2. Now this is a positive number. I have no idea what number this is. That's when you would get out a calculator, plug it in, and see. So you have an idea of where it is. 1/3 times ln of 1/2. Oh, it's not a positive number. It's a negative number. Oh yeah, ln of 1/2. Yeah, that's definitely negative. Negative 0.23. Okay. Alright, so as you can see, this interval, this number line gets split up into two sections. The red section and the blue section. What's really nice is negative 0.23. I could pick a test value here of 0. I'm also going to pick another really easy test value, negative 1. Okay? Now we just need to find the sign of this interval, the sign of this interval. So it's plug these in pretty much like we're doing the increasing, decreasing test. We don't need the greater than or less than zeros though. So plug in negative 1. So test value, negative 1. So f prime of negative 1 is equal to e. If I plug 2e, that's going to give me a negative 2 minus e to the first. I have no idea what this number is. So this is when you come to your calculator. 2e to the negative 2 minus e. Let's see. Yeah. And you get negative 2.44. Again, we don't care about the number. All we care about is that it's negative. So in this interval, it is negative. Now we do the same thing. We find f prime of our other test value, 0. This one's a lot easier to do. 2e to the 0 minus e to the 0, which is 2 times 1, which is 2, minus 1, which is 1. This is a positive number. So on this interval, it's a little cluttered right here, so this is our c value right here. So on this interval, we've got a positive number. So what we can say we could say our function f has a local. Now this one is going to be it's going from negative to positive. We're going from a negative slope to a positive slope. This is a local min at x is equal to 1/3 ln of 1/2. Okay, so again, just to recap, if the first derivative test, if you first find the critical numbers, it splits up the number line, your domain, and then you pick test values and you look at the signs of those and apply the first derivative test. Okay? You are going to need the first derivative test for the test. I am going to ask you a question to apply the first derivative test, so make sure you know it, okay?